Welcome to Module 2. This is where we're going to cover basically two ideas. We're going to cover, well, three technically. We're going to cover systems of equations. We're going to cover factoring. And then we're also going to have one little extra idea, which is called long division, polynomial long division to be more specific. So in this one, the big thing is, there's really two main ideas. It's the systems of equations and the factoring. And then, of course, we have the long division that we're going to tack on as well, too. So first things first, Chapter 2 is about the systems. Chapter 3 is about the factoring. So let's go ahead and start talking systems of equations. Okay. And so section 2.1 is kind of the basics, just giving you some heads up and reminding you about what systems are. So systems of equations. We're going to keep things simple for us. And what systems of equations are is a set of two or more equations that we want to solve. Okay. It's a set of two or more. When you get to college algebra, you'll be doing like three sets, have the possibility of doing three sets. Also nonlinear sets in college algebra. But for us in intermediate, our set of two or more equations, and it's only going to be two, is going to be linear equations. That's what we're going to work with. Okay. So our system of equations, we're going to be dealing with linear equations. All right. But just so you know, they don't have to be linear. When you get to college algebra, you'll see that. Okay. So a system of equations is a set of two or more equations that we want to solve. In other words, we want to figure out what x and y equal for these two sets. Okay. All right. So there are three methods to solving systems of equations. Okay. So section 2.2 is going to cover graphing. That's what section 2.2 will be about. Section 2.3 will cover elimination. And then section 2.4 will cover substitution. Okay? So in the graphing, it's going to be very important that you have your TI-84 calculator, because I'm going to show you how to deal with graphing on that, and how, we're going to use that calculator to help us out really fast. Okay, so definitely make sure that you have your TI-84 calculator. And the best part is we're graphing lines. I've already shown you how to equate lines on your TI-84. So it's just going to kind of be a little bit more review. Just we're going to be working with two of them at the same time. And then elimination and then substitution. Both of these you learned in Algebra 1. Okay, so this is 2.3 and substitution is the 2.4. Okay. So we got these three methods. These are the only methods we use to solve systems. These are the only methods we use to solve systems. Okay? All right. Some other things. So let's talk about the types of solutions you will have. So using one of these three methods, it doesn't really matter which one you use. They all have their, advantages and disadvantages, which we're going to talk about. So we have three types of solutions that are going to happen. So the first one being one solution. This is what we hope for. And what it happens in a one solution, you end up with a point. All of our answers for 2, 2, 3, 2, 4 are points. Okay? And x comma y. Graphically, if you were to graph them, it means the two lines would hit each other at a point. So it's this red dot that we're after. If you're looking at the equations, you know that you will have one solution if the slopes are different and the y-intercepts are different. In an equation, you usually end up with one solution when the slopes of the lines are different and the y-intercepts are different. That guarantees you a one solution. Okay? All right. Another type of solution you can end up with is an infinite solution. So infinite solutions, that's sideways infinite right there that you see. It's kind of like a sideways 8, which I think that's what I did to get that symbol anyway. If you graph it, it's going to look like one line, which makes sense because if both of them are the same line, then they have infinite amount of points that they share in common. Okay? So infinite solutions, when you graph them, they look like one line. Equations, the slopes and the y-intercepts are the same, which makes sense because they're the same line. If the slopes and the y-intercepts weren't the same, then they wouldn't be infinite. They would look like two different lines. Okay? And then last but not least, we have, you guessed it, no solutions. So circle with a line through it, or as you would put in My Math Lab, these are the DNEs, does not exist. No solutions, the lines are parallel. The lines are parallel, which is why they have no solution, because they will never intersect. They will never have anything in common. Equations, the slopes are the same, which makes sense why the lines are parallel, but the y-intercepts are different. Slopes are the same, which is why they're parallel, and the y-intercepts are different. Okay? So throughout this section, 2.1, throughout this section, before I get to what I just showed you, they're basically going to be asking you true or false, or select all the answers that are possible. Like, for instance, they're going to do this one. I know they're going to give you this one. It's going to say, hey, select all the methods possible for solving systems. And they're going to have all sorts of different methods up there. Like they might say the quadratic formula, complete the square, graphing, elimination, using square roots, substitution. All you have to do is make sure that you select these three. There are only three methods to solving systems. Okay, other things that they're going to say are they're going to give you true and false questions. Okay, so an example of a true and false question would be true or false. Parallel lines have infinitely many solutions. And we know that's false. Okay, because if you look down here, here are my parallel lines. They have no solutions. So a majority of this is made up of that. Okay, talking about how many solutions, true and false questions. So like another one would say, if two lines have the exact same equation, or sorry, two lines that have the exact same equation will intersect at how many points? Two lines that have the exact same equation will intersect at how many points? And then you'll be like, oh, it's talking about this, where the slopes and the y-intercepts are the same. They will have infinitely many points. And so there will be four choices there. It'll say infinite, 0, 1, and 2. So you select infinite. Okay? So those are the kinds of questions. They're straightforward about this generic information that I talked to you about here. All right? And then last but not least, you will have, looks like, 3 of these. And they want to know, is this a solution? So what they're asking you to do is plug it in. Whenever you want to check to see if something's a solution, all they want you to do is plug it in. Okay? So remember, this is X and this is Y. If this is a solution to the system, it must be true in both of these. In other words, when I plug 0, 4 in, I have to get 11 out. And when I plug 0, 4 in, I have to get negative 3 out. If I don't get 11 or negative 3, stop, you're done, not a solution. Okay? So let's plug in 2, X is 0, plus 3 times 4. Is that 11? That's the question. Well, 2 times 0 is 0. 3 plus 4 is 12. Does 0 plus 12 equal 11? No. So is this a solution? No. If it did equal 11, then I would plug it into the next one. And as long as this equaled to -3, I would have said yes. But because it didn't work here, because 12 is not 11, the answer is no, it's not a solution. Okay? Try this one on your own and go. Okay, so this is your x, this is your y. Let's plug in. So x is 2 plus 2 times y is 1 equal to 4. So the question is, does it really equal 4? Well, that's 2 plus 2 times 2, or 2 times 1 is 2. So does 2 plus 2 equal 4? Yes, indeed. So now we check the other one. So far, it is a solution. So let's check this guy. 5 times 2 plus 10 times 1. Is that 20? Well, 5 times 2 is 10. 10 times 1 is 10. Does 10 plus 10 equal 20? Yes, indeed. So is that a solution? Yes. Because do you see how it is true for both equations? This gave me 4, and 2, 1 gave me 20. So it is a solution. There you go. And if I remember right, yep, that's it. And that, my friends, is section 2.1. Have fun.